This part, we want to talk about perhaps those that are responsible more for procurement, design, purchasing, big picture kind of stuff. And let's talk about getting a new system or a major revamp of an existing system. How do we avoid paying for something that's not going to work? Or how do we avoid overpaying for a system that we need? Well, I want to tell you a brief story. A long time ago, I went to a large facility that had several dozen dust collectors in it. And as we were doing the inspection, um, I remarked to the person taking me around that every single dust collector was a different brand, different filter size. A lot of them were bags, some were cartridges, some were envelopes, like every possible thing. It was like a bag house museum in there. And I asked him, how in the world did you end up with so many different things? And he told me donuts. And I said, how did donuts mean this happen? And he said that that particular facility, purchase of dust collectors was done by project engineers. And he said that basically whenever a baghouse project would come up, dust collection project, whoever of the local salespeople that would stop at the plant randomly, whoever stopped in with the best box of donuts was the person that got into the meeting, and then the person who ended up selling dust collector, whatever brand or whatever thing they had to sell. So the different engineers always bought them. So basically, the choice of dust collectors they had was based on kind of donuts happened. So it goes to show that sometimes we're our own worst enemy when it comes to selecting the kinds of systems that we want. Whether we pay too much or we get the wrong kind, or a little bit of both. How can we avoid that kind of situation happening at our facility and projects that we're managing? So if we go to our first slide, you'll see we have a few things we want to educate you about that'll help you make sure you don't have this kind of situation happen to you. But all of it has to do with doing your own homework. So you educating yourself before the process starts is the key to making sure you get the system that you need, the system that you want, and that you pay a reasonable price for it. So let's talk about a couple of these concepts as we go through, and you'll see what we can research and why it's important. So the first one, if we go to our next slide, is airflow. So airflow through the system is the whole reason we have the bag house, right? We're looking to move a certain amount of air that's contaminated with dust and filter it. So how much airflow do you need? How much CFM, cubic feet per minute of air, does your system need to handle? Well, in general terms, the larger the space that you're trying to vent, or the greater number of pickup points or drops that you have on the system, the more airflow you're going to need. Now, the airflow is generated by the system fan, as you know. So if we need more airflow, we need a larger fan that can generate the required airflow to handle all of our different pickups. And then we take the amount of air and the kind of dust application, other factors, and then we have to find the dust collector that's the right size for that airflow and the application that we're doing. Now, something to think about. If we don't have enough airflow, what happens? It's not that the bag house either works or it doesn't work. It's not a light switch. What happens is you have a bag house that can work really well, okay, not so great, poor, and then you have one that just works terribly. So most people may have only ever experienced a dust collector that works poor or maybe okay. And for them, that's their concept of how they work. Other people have only ever seen like the greatest dust collectors ever, and they're designed really well in size and think they're always perfect like that. But a lot of this comes into having the right airflow. If we don't have enough airflow, as we see at our pickup hoods, what happens? It's not that all of the dust falls out and it's all over the floor. It's usually that the system collects some of it or most of it and then leaves dust around the pickups. Or maybe there's fugitive dust that floats away and then goes and settles elsewhere in the facility in the nearby area. That's what not having enough airflow looks like. Or we have a lot of buildup in the ductwork because the material doesn't move fast enough because there's not enough airflow. We'll talk about that one in just a moment. But that's why it's important to have enough CFM for the system for what you're planning to do with it, whether it's a pickup hood, whether it's a process that's plugged right into it, venting a silo, whatever it is, you have to have enough airflow. And you need to know this more or less before you start talking to a dust collector vendor. Now let's go to the next slide. Our second thing you should have a kind of a concept of is static pressure and vacuum pressure. which really is, as Matt just went over, really just means the resistance and the suction you need. So the resistance is the resistance to airflow created by the pickup hoods, all of the ductwork, any items that go in the ductwork, like combustible dust protection devices, valves, dampers, diverters, spark traps, and then the resistance that's created by the bag house, and then the exit exhaust stack itself. So all of those things together becomes the static pressure or the resistance, and it's measured in the same thing as the differential pressure in the bag house, inches of water. And in fact, the differential pressure in the bag house is just the measurement of the static pressure the bag house creates, or the resistance it creates, in real time. So generally speaking, the bag house is the only thing that changes the resistance. Whether the filters are dirty or clean, the resistance it makes goes up and down. The ductwork pretty much stays the same no matter what you do, unless you change how much air is going through by a lot. So that's why we monitor the differential pressure a lot. Why does this matter for when you're selecting the system? We're going to ask for quotes. Because when you size the fan, you need to know how much resistance you have to overcome to get the right size fan. Sometimes people think that it's just that this fan does 10,000 CFM, this one does 20, this one does 50. But actually, it's not just the airflow. If you read the full spec, it's 10,000 CFM at this static pressure, 10 inches of static pressure. And as Matt explained, what does that mean? It means that when there is 10 inches of static pressure in front of the fan, so all the ductwork, the bag house together makes 10 inches, this fan will create 10,000 CFM of airflow through it, right? And that's a simplification of how fans work, but that's the basic idea we want. This is important when you're procuring a system because when you write your spec for what kind of fan you want or how much airflow you need to tell the fan supplier whether you need this much static pressure or a lot of static pressure. So if you're just collecting, if you have one short little run of duct with one pickup hood, you probably need just a little bit of static pressure on the fan, or vacuum pressure, sorry. You need just a little bit of vacuum pressure to overcome that resistance. Whereas if you have a big spidery system with lots of little branches or really long runs of duct, you need to make the fan have a lot of suction on it to overcome all of that. And the difference between a fan that does 10,000 CFM at 10 inches of resistance versus a fan that does it at 25 inches is enormous in the cost, the power, how much it costs to operate it. So it's really important if you're trying to get that apples to apples comparison, or just the one that you need, not undersized to make it cheaper. You need to call that out and have an idea of what's required before you submit the project out to get bid on. All right, if we go to the next slide, another thing you should have in mind a bit is air velocity and the minimum conveying velocity for your application. This is especially important when you're talking about the ductwork design. So some users might design the duct themselves. Sometimes they hand it off to the dust collector supplier, or they might hand it off to an engineering firm or a third party. In our case, for example, at baghouse.com, most of our customers ask us to design the ductwork system as part of our package. And we're able to do all of that together. That's one of our benefits of working with us. You can do the whole complete pickup hood through ductwork to the collector, the fan, design the whole thing as one big package. But in any case, it's good if you have a general idea of the velocity that you need for your system, because there's two problems. There's the problem of having too high a velocity and then having too low a velocity. If the velocity is too high, you can wear holes in the ductwork because the material is abrasive a lot of times. So you blow out the elbows. You can also waste a lot of energy, power, because pulling something too fast through the ductwork faster than it needs to go, it very quickly becomes very energy intensive. So you don't want to move it faster than it needs to go and be wasteful. It also, in certain applications where you're conveying like a finished product, like some food materials, for example, moving it too fast can cause it to break up and cause a wear and other effects like that we want to avoid. But more importantly, or more often, low air velocity is the problem we want to avoid. So you have our picture here. Every material that we work with has a certain velocity that it needs to move at in order to stay floating in the air. So if you have a heavier material, if we have flour versus lead dust, it's going to need to move faster. But also if you have big pieces versus small pieces. So a grain of lead dust is actually not heavier than a big chunk of wood that's getting sucked through the system, right? So the bulk density of the material, but also how big the particles are, what exactly you're moving. All of that goes into determining what's called the minimum conveying velocity. That's the slowest possible speed that you need to move the material so that it stays floating in the air. If you go lower than that at any time, what happens is what you see in the picture, where you have the dust builds up in the bottom of the pipe, and then you get all kinds of other knockoff problems. You get restriction because now the pipe is smaller inside, so it actually speeds up the air, causing abrasion after it. You also get where it can create more resistance, so it lowers the airflow through the whole system, it plugs it up. And in the case of if you're handling combustible materials, these become especially hazardous because any spark or ember that you suck up could land in any of these accumulations of dust and then start to smolder, create a fire or an explosion. Or if there's an explosion or fire somewhere else in the system, if it propagates through the baghouse and the ductwork, when it finds these large pockets of material, it'll dislodge them and create a much bigger explosion, fire that's quite hazardous. In fact, most really devastating dust explosions happen not because the baghouse exploded. It usually happens because the explosion goes backwards and finds these accumulations in the ductwork. So having a general concept of what velocity you need to move things at will help you when designing your ductwork to make sure the system works well. In general, just for your knowledge, in general, most materials for our purposes are between 3,500 and 4,500 feet per minute. Some need to go a little faster, some can go a little slower, but that's generally the range that we work with dust collection. Okay, let's go to the next slide. Now here's a fun one, air to cloth ratio. This is our shorthand in the industry for sizing the baghouse. Many people will ask us, I need a 10,000 CFM baghouse. Or you might even see listed a lot of times for used equipment, people will list it and say, this is a 10,000 CFM baghouse. This is incredibly misleading because there's no such thing as an airflow rating for a dust collector. Why is that? Because how much air that dust collector can handle is entirely dependent on the application. If you are collecting a little bit of welding smoke in a shop, it is completely different than if you are collecting frac sand from a giant dryer and moving tons of material per hour through the baghouse. Completely different. So be wary of anyone that tells you this unit does this much. They should always tell you this unit in this application with these specs can do this much. That's how it should be. So you need to have an idea of roughly the air to cloth ratio you should have. So in most cases, we want to do with pulse jet baghouses, something like 4-to-1 to 6-to-1. You can go a little more than that. Sometimes you can go a little less than that. But generally speaking, the more dust you collect and the harder the dust is to collect and remove from the filters, the bigger the baghouse needs to be. So bigger meaning the number of filters and the surface area of the filter. So that's what our slide here says. We do the air to cloth ratios. We take the airflow in CFM and we divide it by the square footage of the filter media. So for example, a normal baghouse with 6-inch bags that are 12 feet long, those bags have about 18.8 square feet of filter area on each bag. So you calculate how many bags you have, you get the square footage, and then you take the airflow you want, and you can get that ratio. Different collectors have different ratios. So cartridges, for example, are much lower, like 2-to-1 or even 1-to-1. You might see also some reverse air rotating jet collectors go higher, or bin vents, for example. The reason you need to have kind of a number in mind, and you can get this by researching online, like on articles on our website or by talking to a consultant, is because the number one thing people will do to sell you something is tell you that their dust collector can do the same amount of airflow as the other guys, but be half the size. And obviously the reason they tell you that is because then theirs looks cheaper and you want to buy that one. But the result of that is that you get a system that's undersized, which we'll talk about a little later what that looks like. But it's not going to be that bag house that works excellent. It's going to be that bag house that works meh to not so great to horribly. So having that in mind, that range that you want will help avoid that. Also, it's good to know what this is because if you're looking at multiple bids from different vendors, you can compare very quickly the differences by seeing what the relative sizing is of the different collectors. Because if they use different size filters or configurations, it might be hard to see why the one that has 100 filters is a better option than one that has 150, but they're smaller, for example. Okay, let's go to the next one, Andy. So our last one we'll talk about real briefly is the type of collector that you need. So Scott mentioned this a little bit earlier, right? We have things like cyclones and stuff like that. That really, for most people, we're not going to be able to use as the final collector. We might use a cyclone or a knockout box to lighten the load or for some other reason going before it goes to the bag house. It's not going to be the final collector. But when it comes to our fabric filter collectors, our bag houses, cartridge collectors, and then even what kind of bag house we use, there's a lot of different options. And this is where a lot of people get in trouble. This is where we get the box of donuts problem. Because many people who sell dust collectors, unfortunately, are not very qualified to do so. So obviously, we think our brand of bag houses is the greatest, most amazing thing in the world. And it is. But there are a lot of other vendors that are very reputable that make really good systems too. But a lot of the people who sell dust collectors besides them, a lot of them are sales rep organizations, and the people that you might interact with don't really know everything about dust collectors. Or they're not trained, I should say. Nobody should know everything. More accurate is to say they're not really experts at dust collection. Or another common problem is they might only rep a certain supplier that only has one kind of system. Maybe they only make this kind of bag house, or they only make this kind of cartridge collector. So naturally, as all good salesmen will do, they'll try to sell you the thing that they have because that's all they've got. And they'll tell you everything that's good about it. You're not really getting the full picture, though, if you deal with someone that only has a limited product range. That's why a lot of companies like us and some others, we make all different kinds of bag houses, dust and cartridge collectors and things like that, because we know that one doesn't fit everything. So just having an idea of what kind of system you need will do a lot of good for you. So for example, bag houses, we like to say are kind of like the pickup trucks of the dust collectors. They're rough, they're hardy. You can tow a lot of weight behind. You can drive on the road. If you get the big one, you can have a lot of people inside. You can do it pretty much anything with a bag house. Now, cartridge collectors, though, offer a very good alternative sometimes because they're smaller, more compact. So they're cheaper to make, cheaper to run. They're a little bit easier to work on, changing filters. They're really good for applications where you have a light dust, or maybe you have a lot of air you have to move, but a little bit of dust. Think like a welding application. You got to move a ton of air from the whole building, but only a little bit of dust. If you had a bag house do that, it would be huge compared to a cartridge collector. So a cartridge collector, they're great. We use them in a lot of applications, but they're really more like a van, like a minivan. If all you're doing is moving a little bit, a small group of people around all the time, it makes more sense to have a van than to have a big pickup truck, right? But you would never use the van to try to pull a big trailer to go off-roading, right? It just wouldn't work. And the same thing happens with cartridges a lot of times. They get stuck places where they have no business being, either because it's the only thing the sales guy has in his rep, in his thing that he reps, or because everybody else quoted a bag house and he wanted to be cheaper, so he tells you can use a cartridge collector. You also have the option of pleated filter bags, which are kind of a mix between the benefits of a bag house and the benefits of a cartridge collector, kind of like an SUV, right? So they have some of the benefits of more filter area like the cartridges, so the bag house is smaller, but they're not so tightly packed like the cartridges. They're more like bag houses in that sense, where it's a bigger, easier for the dust to fall off. So you can use them in a little bit more difficult applications that a cartridge wouldn't use. And then the only other one I'll mention is just the reverse air bag houses, the rotating arm reverse jet. They go by a bunch of different names, but these are the ones with the big cylindrical bag houses. And they have the rotating arm that goes around, pulsing back into the bags at all times, kind of a combination like a pulse jet and a reverse air bag house. These work very well for certain applications. They work really well with things like grains and sometimes sand and wood applications. But in other applications, they do not work well compared to a pulse jet bag house. And depending on how you compare them, it can look like they're a much cheaper option, but they're really not going to work anywhere near as well as a pulse jet will, which is that, again, that heavy duty big truck that's going to work really well. So having an idea before you get started of what kind of dust collector you need is going to help you avoid falling into that trap. Now, just in conclusion of this section here, what are two things that we want you to be aware of? Well, first is find someone that's a trustworthy OEM to design and install your system. Or another way you could do it is have an engineering consultant or an OEM work as your consultant and help you develop a spec that you can use to then go out for bids. This helps avoid a lot of those conflicts of interest, but it also makes sure that you're getting someone that's designing your system that has access to all the different kinds of technology available, not just pigeonholed into one particular model or brand of dust collector and then trying to make your application fit into their little box. No, have access to everything so you get the system that you need. Now, one other thing we want to tell people to be aware of. Go to the next slide, Andy. Be aware of claims about miracle solutions. This happens all the time where we work with a customer and they say, oh, well, we were told that this new technology was the greatest and the best thing ever, and that we could do 3 times the volume and it would be half the size and half the cost. So just a few things we tell people to think about. When you hear things like that, think for a moment, if it's really that great, why doesn't it dominate the market? Why isn't that technology the market or industry standard? Why doesn't everybody else imitate or copy them if that's the case, if it's so great? A lot of times companies will try to use a old idea that's been discarded by the industry or come up with some novel idea. They change the shape of the cartridge slightly, for example, and then they say that it's amazing. A lot of times it's just because they want to stick you with something that's a proprietary design. You know, it's like Gillette selling the razor at a loss, and then the cartridges that they sell you, they have a huge markup on. That happens quite a lot in dust collection. Other times they have things that might, it's great, try new things and new shapes, new types of filters. They might work well in lab, but in the real world, we know from experience they don't work very well. So they should keep trying to invent new things, but want to make sure that we don't get stuck with that. And then the second thing, if we go to the next slide, Andy, we just want to make sure to avoid getting solution. I thought we had one more. Okay. Well, just one other thing with miracle solutions is make sure you don't get a system that's undersized. As we said, when you get comparative quotes, try to make sure it's apples to apples. And the main thing to watch out for is if somebody's trying to give you a more aggressively sized system, claiming that it'll work fine. It'll work just well enough that you can't sue them afterward and say it didn't work, but it's not going to work as well as the one that's properly sized. So look for those things when comparing. And in all of this, in summary, we can just say educating yourself beforehand is the key to avoiding these problems. So you're not going to learn everything. You're not going to become a dust collector expert, but being an informed end user, informed consumer, having this nice general knowledge of these few key areas, it's going to help you look for the important things on those proposals that you see. And it's going to help you avoid overpaying for a subpar system that's not going to work and not deliver the performance that you need. So as I said, we educate ourselves to an extent, but we need to when we're coming up with a system design or running that kind of project. But learning about dust collection can have a lot of benefits, whether you're from management all the way down to technicians, engineers, environmental and safety people. Whatever it is, learning more about dust collection really does benefit your organization, your plant, and your individual employees on many, many levels.